All right, friends, here we are on page 3. This is number 5. No, I'm sorry, number 6A. All right, you're still with me. I'm so sorry. I'm sure this is not super exciting. Okay, so the directions say divide using long division, check your results using the remainder theorem, and then answer, is it a factor? So we have to go through all that good stuff. So here we go. Long division is a fun little beast. Okay, and then go ahead and get our problem set up. Cube squared 1. Okay, here we go. I'm going to ask myself the same questions over and over, so you'll hear, hopefully if you miss it the first time, I don't hope you miss it the first time, but if you miss it the first time, you'll hear it repeatedly, so don't give up, try and get your brain going, and if you're having a hard time with this. The question you ask yourself is, x times what gets me x cubed? And the answer is x squared. So now x squared times x is x cubed. Don't forget though, you're basically doing distributive property with this x squared, and now it's got to go to the x and you've got to do it to the 2. So this is plus 2x squared. Now here is super hard part. Now you have to subtract, and when you subtract, it changes the signs of everything that's here. So this becomes a minus and this becomes a minus. So if you've done it correctly, you should get a 0 right there, which we did. And this is going to be 5x squared minus 2x squared, which is 3x squared. Bring down the 9x. You could also bring down the 6 if you wanted to, and if I need to, I will, but for right now, that's enough. Now I start that entire process over again. I ask myself, x times what would give me 3x squared? Because I want this exactly. So I need to multiply it by 3x. Would that give me a 3x squared? Yes, it does. And then the 3x now has to be multiplied times the 2 as well, so that's plus 6x. Draw a line and subtract. When you subtract, it's going to change the signs of both. This gives you a 0, which it should, and this is 9x minus 6x, which is 3x plus 6. Okay. I got to keep going. So how do you know when to stop? When this right here is a higher degree than this one, you can stop, but right now they're equal degree. This one's an x and this one's an x. If this was x squared and this is an x, you'd be done. But right now I can keep going. Ask yourself, what do you multiply this by to get 3x? And the answer is 3. So if I multiply those, that's going to give me 3x, and then 3 times 2 is 6. Draw a line. When you subtract, it changes the signs, and I get a 0. Okay, so x plus 2 times x squared plus 3x plus 3 equals that nonsense. Yay! So I did my long division. Now I need to go and answer my other questions. Use the remainder theorem. The remainder theorem is when you go like this. Ooh, tricky business. Oh, like this, you couldn't see it. When I use f of negative 2, so now it's hard on here because you can't see everything, but I'm going to go up and I'm going to grab this equation right here from my original, the x cubed plus 5x squared, blah, blah, blah. And then why did I use negative 2? Because that says x plus 2, and I need to make sure that I'm using what the 0 that goes with that is. All right, so here we go. I'm going to take that original up top. X cubed plus 5x squared plus 9x plus 6. And so it's going to be negative 2 cubed plus 5, negative 2 squared plus 9, negative 2 plus 6. And now it's just math. This is negative 8. I'm sure you're using your calculator. This is 4, so 20. I'm just too lazy to go get mine. Minus 18 plus 6, so that's going to be a 2, 8, negative 8. This is 0. Nailed it. That was what I expected to get because I know that my remainder over here was a 0. So I've just verified. I've checked my results. You could put a cute little check if it makes you happy. Is it a factor? Yes. X plus 2 is a factor. How do you know? Because of the 0 remainder. I don't know if you just heard that. That was my dog. And he's real tough. I'm not sure what he's doing. Okay. So here we go again. Do-overs. Let's go again. Fitz, lay down. Okay, so x times what is x cubed? That would be a cute little x squared. So that's going to be x cubed minus x squared. Draw your line, and now subtract. So now look at this. When I go to subtract, that's going to make this one minus, but it's going to make this one a plus. Gives me a 0 there. And now I get 3x squared. I'm going to bring down my minus 2x. Okay, now the question is, x times what gives me 3x squared? 3x is the answer. So now I multiply those and I get 3x squared minus 3x. When I go to subtract, it's going to make this one negative and it's going to turn this one to positive. That's a 0, and now I've got an x here. Minus 3. So x times what gives me x minus, or gives me an x. So that's going to be tricky business. That's a 1, actually, plus 1. So 1 times x is x. 1 times negative 1 is a negative 1. I'm going to draw the line. This is a minus. This is a plus when I switch my signage. That is a 0 and a negative 2. Ooh, sorry, negative 2. So this is my remainder. The question is it a 0? No? Then that means that it's not a factor. That means that x minus 1 is not a factor, to be more specific. So if I were to multiply these two things together, boom and boom. Oh, if I were to multiply these two cuties together, I would not get my original. I would need to subtract 2 from it to get the original. So no, x plus 2 is not a factor. I probably should have done that down below to be consistent. Oh boy. Okay, there you go. I am going to do f of 1 and put that into the original that's up here. I'm using f of 1 because this says x minus 1, so my possible 0 would be a positive 1. And then I'm going to use that right there, but it's off of my screen, so you'll have to look at your paper in front of you. So x cubed plus 2x squared minus 2x minus 3. Plus 2 minus 3. So that's 3 minus 3. That's a negative 2, friends, which we expected. Okay. Not a factor. I think we've answered all the questions there and did all the things we were supposed to. So now we come down here to 7a. Look at us making real progress. It says divide using long division. I would rather use long division here than synthetic, probably. I mean, it'd be pretty similar, but I think it's easier just to do this. All right, so 2x times what would give me 2x cubed? X squared, I think. 2x cubed plus an x squared. Subtract, that means you flip both of your signs. That gives me a 0, and that gives me a 0. Oh, that's interesting. Let's see how that affects things. I'm going to bring both of these down now just for fun. So now the question is, 2x times what gives you 6x? So that's going to be just a cute little 3. Gives me 6x plus 3. Subtract, and then subtract that, you get 3, my remainder. I know to stop because this is a lower degree than that. Okay, and so I was just supposed to divide. So 2x plus 1 times x cubed plus 3. Oh, not cubed. Cute little 2 right here. So 2x plus 1, x squared plus 3. That would not get me what I need. I would need to add 3 to get what I want. Okay. And then here we go. Okay, this one has to be done. I cannot do this one with synthetic division because it's not linear. As soon as you've got something squared or higher, you have to do long division. It's the only way. All right. It's going to be a little dicey because there's no x term there. Ooh, and then look at this up here. That's going to be interesting. So I am going to, you see how there's no cubed term? I'm actually going to put in 0x cubed as a placeholder. Then minus 2x squared. Do you see how it's missing the x term? So you guessed it, I'm going to put 0x, then minus 3. So it only had 3 terms, and now I've got 5 because I put in 2 fake ones as placeholders. so that when I go to multiply things, I have a place to put it. And sometimes I need it and sometimes I don't, but I'd rather have it there than not. So x squared times what gives you x to the fourth? I think that's an x squared. So that does give me x to the fourth. Now, where am I going to put this x squared? Oh, I'm going to put it right here, so I don't know that I needed the x cubed term. I'm going to subtract, so that's a 0. I don't need to bring this down unless, I don't think there's any reason to. These guys right here give me minus x squared. And I'm going to go ahead and bring down the plus 0x, but I'm also going to bring down the minus 3, or negative 3, depending on how you look at that. X squared times what gives me negative x squared? So that's a minus 1. So I get minus x squared minus 1. Make that a plus, make that a plus. That goes away, and I get a negative 2. Am I right about that? Looks good to me. Okay, so that means x squared plus 1, x squared minus 1, minus 2. Cool. And there is the conclusion of, I don't know if we're on, I think page 3 now.